This lecture is about dilutions, which is very related to molarity, which, remember, is a unit of concentration that we use for solutions. However, the concept of dilutions can be applied to any other concentration. But for now, we will stick just with molarity. So let's start by defining what is a dilution. Dilution is simply the process of altering the composition of a solution by adding more solvent. That's the only thing that you're changing. You are not changing the amount of solute, and it's important that you don't change it, because if not, the concept of dilution goes away. So during a dilution, all you are doing is adding more solvent. Water, for that matter, is the most common that we're going to use. So the important thing here is that the solute, the amount of solute, doesn't change. You're just adding solvent. So the amount of solute doesn't change. And that is very important, because if not, we cannot apply the concept of dilution. Okay, so here you can say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 particles of solute. You're gonna see the same number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in the second case. You just change the amount of solvent, you change the amount of water, if that's the case, but you are not changing the amount of the solute that you have there. Okay, of course, you have an initial volume. You will have a final volume. The final volume is changing because you are adding more solvent, and the final volume, when you are doing a dilution, that final volume is going to be larger. Okay, so the final volume is larger if you are not changing the amount of solute. And remember, molarity equals moles over volume. If the number of moles don't change, but the volume is larger, then concentration decreases. Okay, as long as you don't touch the amount of solute that you have in that initial solution, the concentration is going to decrease, because you are increasing the volume of the solution. So why would you do a dilution? Why is it useful for? Okay, so normally when you are working with solutions, a common practice is to prepare a concentrated solution and then you store that, and you call that a stock solution. It's just a solution that you have in storage, and from which you can take whatever volume you want to prepare a solution at a different concentration, usually a smaller concentration. Okay, and all you have to do is add more solvent. So you already have a solution, that's the amount of solute fixed in that solution. If you want to prepare a different concentration, a lower concentration, then all you have to do is take a smaller volume, add more solvent, you get a diluted solution. And you want to do that because when you are measuring volumes, you can do that more accurately and more precisely than measuring masses. Okay, it takes longer, and so measuring volumes is also faster. So you can measure it faster with great accuracy and great precision that you can do if you're focused on masses. Okay, so that's why you prepare dilutions. Now, how do we use dilutions in calculation? Because after all, this is all that matters at this point. How can you use dilution in calculation? So let's focus for now in the moles of solute. And what we are saying about moles of solute is that they are constant during a dilution. It doesn't change, because all you are doing is adding more solvent. And if we are talking about concentration, and we are talking about molarity for that matter, because that's the unit of interest here, what we know about molarity and the relationship with moles of solute is that the molarity, it tells you the relationship between the moles of solute and the volume of solution. Okay, if you divide moles by volume of solution, you obtain molarity, and then you already know how to work that around, right? So the thing here is that because you are doing a dilution, meaning you will have, or you at some point you will see two different solutions. They are made out of the same components, but they are different because they have different concentrations. So one is going to be your diluted solution, and the other one is going to be your concentrated solution. Let's say, for example, we call this solution 1 and this is your solution 2. Okay, so if the moles are constant, and remember, molarity is moles over volume, therefore, let's write that down here. Molarity is moles over volume, which means that number of moles is molarity times volume. So that's how you calculate number of moles based on the molarity and the volume of solution. Now, the number of moles are constant because you are not changing. You are changing the amount of solvent, but you are not changing the amount of solute. So the number of moles of solute will be constant. So no matter what volume and what molarity you use, you have to obtain the same number. And that leads us to the dilution equation. Okay, this is your dilution equation. And remember, it's only for dilutions. More on that as we move through the class. But this is just your solution 1. And it doesn't matter if you call that the concentrated or the diluted. It doesn't really matter. It's just solution 1, and then you have the solution 2. And basically what you're saying is the amount of solute in those two solutions is the same. And that's how you calculate it, because the amount of solute is the same. The product of the molarity times the volume has to be constant, okay, for those two solutions. So how do we use these in calculations? So let's see an example here. We have a solution that is 0.875 molar in sodium hydroxide, and you start with an initial volume of 145, and you dilute that to a new solution, a new volume of 225 liters. Okay, initial volume 145, final volume 225, and this is your initial concentration. So remember your dilution equation: M1 V1, M2 V2. So the key to success in this type of problems is to assign those variables correctly. So who is M1, who is V1, who is M2, and who is V2? So let's start M1, and basically you can assign M1 to the first concentration that you see in this problem. So M1 is going to be 0.875 molar, and that 145 liters go along with that 0.875 molar. So V1 is 145 liters. The next quantity is a volume. So if you already identify that 145 as volume 1, then volume 2 is 225. The question is, what is the concentration? So M2 is what we are solving for. So in this dilution equation, we are solving for M2. And M2 is going to be equal to M1 V1 divided by V2. And this is 0.875 molar times 145 liters divided by 225 liters. If you are increasing the volume, you have to end up with a smaller concentration. M2 is 0.564 molar. Okay, you started at 0.875, you end up with 0.564, smaller concentration. It is a dilution. In this case, we have a volume with a certain concentration. So let's write this down: M1 V1, M2 V2. So M1 is going to be, I'm sorry, I should start with V1. V1 is 0.17. You know what? Let's erase that. 0.17, 18 liters. The concentration is 0.3556 molar. And then the next number is a concentration. So M2 is 0.1222 molar. So we are actually solving for V2. What is the final volume of the resulting solution when you dilute that initial concentration? So we are solving for V2. V2 still is going to be M1 V1 divided by M2. And this is 0.3556 molar times 0.1718 liters divided by 0.1222 molar. You end up with units of liter here. V2 equals 0.4999 liters. And yes, we can agree this is 0.5 liters, but I'm just following the number of significant figures there. Okay? In this case, what is the final concentration? And this is a little bit different. What is the final concentration of the solution when you have 225.5 milliliters of that concentration and you allow to evaporate the solution until the volume is reduced to 45 milliliters? So we've been saying that the dilution is, well, you add more water, but it can also go in the other direction. What if you are able to reduce the amount of solvent? Well, you can do that as long as you don't change the amount of solid that you have in that solution. Well, this problem, even if you are ended up with a final volume that is smaller, it still qualifies for a dilution problem because you are not changing the amount of solute. So, and we can solve it exactly the same way. We have M1V1, M2V2. Here V1 is 225.5 milliliters. M1 is 0.0988 molar. V2 is 45 milliliters and M2 is what we want to know. So in dilution, take note of this. During dilutions, you don't need to convert to liters. No need to convert volume to liters, because in that equation, and just let's do it and you will see it. So we're solving for M2. M2 is M1V1 divided by V2, and this is M1 is 0.0988 molar. The volume is 225.5 milliliters divided by 45 milliliters. So you take a look at the volume and you are canceling milliliters with milliliters, and the same thing is going to happen even if you change that to liters. Okay, so because you are canceling the volume units, there is absolutely no need to change it to liters because you are applying the same factor to each one of those volumes. So this is probably the only case that you don't really need to change it to liters. So here in this case, M2 is going to be equal, after you finish this calculation, is going to be equal to 0.5005 molar. So you are decreasing the volume of the solution by removing solvent out of the solution. Your initial concentration was probably, you can approximate that to 0.1 molar. Well, you are concentrating that solution to 0.5. You are ending up with a larger concentration. Last problem is, how many milliliters of water are required to dilute 205 milliliters of this solution? So this is technically V1, this is M1, and this is M2. So technically you are solving for V2, right? So M1 V1 equals M2 V2. If we are solving for V2, V2 is M1 V1 divided by M2. This is M1 is 115 molar times 205 milliliters. Again, you don't need to convert to liters. And you divide by 0.81 molar. Molar units cancel each other, and you end up with 291 milliliters. Okay, now this is V2. This is the final volume of solution. Okay, but that is not the question. The question is not asking for the final volume of the solution. The question is asking, okay, how much water you have to add to the initial solution so that you obtain that final solution. So water is the difference in volume, basically. So if your final volume is 291 milliliters, then if you take the 205 milliliters, you will end up with 86 milliliters. Those 86 milliliters, they represent water that need to be added. Okay, you need to add 86 milliliters of water to the initial solution so that you obtain your final solution at the desired concentration. Okay, so this is one of the problems that you have to be careful with, because if we are asking for water, we are asking for the amount of solvent, the extra solvent that you have to add. And it's not, the extra solvent that you have to add is not the final volume of the solution. Okay, so that's it for dilutions. We'll work this later in class.